Yeah, go ahead. Yeah, Srinivas.
Yeah,
Yeah, you can start.
okay. So, previous session we discussed about all the components, hardware components which are required for virtualization. Please refer the first 1 and 2 and 3 slide sessions. Windows Server Administration, we discussed about few hardware components. So I'm not going to repeat all those components. Please go ahead and review that hardware components, storage components and network components. Here in this session, I'm going to discuss about only few topics which are very much important for virtualization layer. Okay. So coming to the storage concepts, what is important for virtualization? What we need to understand to work on virtualization? We know this local storage is available for each server. Whatever the hardware server, we are going to talk about going forward only physical server. Okay, physical server, what are the components are required to perform the virtualization? How much capacity CPU, how much memory, how much network, and all those things we are going to review. Okay, so coming to the storage concept, what is a local hard disk, local disk? Local disk in the sense it is a DAS, direct attached storage. Local storage, how we can install operating system that we are aware. For installing an operating system, it requires a local storage. That is fine. How this local storage is limited for virtualization. So, for example, we are selecting a hardware server, and then there is a local hard disk is available. Say 1 TB or 2 TB, whatever the disk is available on local server, that 1 TB is available. What purpose we are using virtualization? We are going to create a number of virtual servers, isn't it? Those virtual servers, what the virtual server is nothing but, the virtual server is nothing but it is the software component, software emulation. That software emulation in the sense it is software code. It is going to create a files according to hardware. CPU means I am going to create some CPU means it is going to create refers to some software code. Where that file is going to store? On the storage. If the storage is a local storage, for example, I'm going to build a number of virtual servers. Say, for example, 15 virtual servers I'm in deploying on this selected server. That is a local hard disk. If I deploy 15 servers on the local hard disk, if something happens to the server, what will happen to the data? It is a single point of failure. So for that reason, this local storage, what is the limitation in virtualization? We need to avoid a single point of failure. If one server is down, what is the impact? We should understand. If 10 servers are there on the same system, if the 10 servers are going down because of hard disk failure, local storage failure, there the concept comes in centralized storage. Centralized storage, what are the components? There are server storage, centralized storage. What is the centralized storage? Two components, NAS and SAN. What is the limitation of NAS? What is the limitation of SAN? What is the cost involvement? Because virtualization, we need to think about in each aspect like what is the cost? What is the organization cost, total cost, ownership? Okay, so what is the limitations of NAS? What is the limitations of SAN? What is the infrastructure we need to make centralized storage? Why this centralized storage is required? In previous sessions in Windows Server, you might have understand the file server. File server in the sense, if the file server, whatever the users, there are number of users, 100 users. If they're keeping they're saving the data on a local system, if something goes wrong to the local system, what happens to the data? So what they're going to do, they'll create a centralized storage, a file server, wherein they'll save all the files on that centralized server, so that can be backup. So they are going to avoid single point of failure. In this virtualization, why we are not going to consider local storage? Because whatever the servers, virtual servers we are going to deploy, those are files, combination of set of files, combination of set of software code. So if the files are going to fail due to hard disk failure on local storage or some other reason, that entire whatever the servers I deployed on that particular hardware, those servers will be down. We cannot retrieve the data. To avoid single point of failure, what we are going to look for in virtualization, centralized storage. There are other advantages also for centralized storage. What are those advantages? We'll discuss later. But in virtualization concept, we have to look for centralized storage. We should not deploy virtual machines on local storage. For example, in our lab, we deployed VMware workstation. On VMware workstation, we created 5 servers. Those 5 servers are storing on a laptop, desktop system. If the desktop system failed some reason, it is not starting, it is not booting, what will happen? I cannot perform any action on those 5 servers. That's the reason we have to avoid local storage. So coming to the centralized storage concepts comes in, there are different components. NAS, what is that? Network attached storage. First, we'll discuss about network attached storage. What is the limitation? What is the benefits? Benefit in the sense, in the network attached storage, we no need to go for additional infrastructure. For every hardware, every server, it is going to work on a network. Network in the sense, we are going to assign an IP address for every system. The network infrastructure will be there, switches will be there, router will be there. That whatever the existing infrastructure is available, the same infrastructure can be used for this network attached storage. Only NAS server is sufficient to deploy my environment. So network attached storage, what is the benefit? It is going to provide limited cost, because we no need to put additional cost to, no need to provide additional cost to deploy this centralized storage concept. Existing infrastructure in the sense, whatever the network switches, network connections are available in environment, the same network infrastructure I can use for this NAS deployment. Only thing is that I need to look for only one centralized storage related to NAS. Once that is available, I can configure existing network infrastructure and then make use of that NAS architecture. So what is the disadvantages in this? The production network, the storage communication, and other whatever the production network, storage communication, all communication is going to happen close through the existing network. There may be chances of network bandwidth. So network bandwidth, it is going to impact if any issue comes in network infrastructure. It is going to create a bottleneck or a transfer rate maybe less or kind of thing. So we are working on virtualization, what is the requirement? We are going to deploy number of virtual servers on a single hardware. If one server requires a high data throughput, whereas in, for example, database application in the sense, database is a disk intensive application. Disk intensive means it is going to keep on write the data, keep on read the data. The DB is going to sends the query and gets the input from the generates the reports. For whatever the action it may be, for DB server, it is going to, there are number of read and writes. That in the sense, the DB server itself requires a high throughput. There less latency should be less latency. What is a latency? The disk, what is a access speed is there, that we call it as latency. So we should not make a trouble of this particular latency and throughput or all those things. If any bottleneck is there in the network infrastructure, because the same communication, the existing network infrastructure is used for all production related network functions, either accessing applications or anything, whatever it may be. At the same time, we are going to use backup purpose. At the same time, you are going to use for this particular storage purpose. All this going to flow through this existing network infrastructure. So some organizations, what they'll do, they'll create a separate network for storage. They'll create a separate network for backup. They'll create a separate network for storage, production network. Even though there is a certain limitation for this network bandwidth. Even I am providing the dedicated storage connection from the virtualization to NAS server through a separate network. That network is not going to come into picture for production network. Traffic is not going to come into picture, or a backup network is not going to come into picture. Other traffics are not going to coming into picture for the storage network. That is fine. But there is a limitation for NAS also. What are the limitations? Okay, we can go through Google and compare what is a NAS and versus SAN. Why SAN? Why SAN? Why not NAS? There are certain limitations and all those things, disadvantages, advantages also available. You need to compare both the things. Like whatever the action we are going to implement, whatever the action we are going to perform, this is all depends upon the user requirement. What is the user requirement? My user requirement is going to fulfill or not. That's what main criteria. The customer is looking for some high-speed network, high-speed data. Then is this NAS is fulfilling their requirement, the customer requirement or not? All those things we need to consider. So what is the NAS requirements? NAS requirement server can be used for existing network infrastructure. For everything, you need to understand what is server, what is a client. The server, both are, I'm telling you here, the NAS is a server, storage server, but additional servers also I am using. Additional servers in the sense ESXi host also virtualization server. But why I'm calling as a server and client? Server and client relation. Who is providing services that becomes as a server? Who is getting the gain, that service that becomes as a client, even though it is running on a server? So that's the reason what I'm going to classification here. I'm going to show you as a what is a server. Server can be used for existing infrastructure. What is a server means? NAS storage server. Whatever the storage it is providing, that storage server I'm talking about here. What is a client? The client can be anything, either Windows server or Linux server or virtualization server. That server is getting the storage from the NAS server. That's a requirement. So both server and client both can work together on the existing infrastructure. No need to deploy any additional components. That is the NAS advantages. There is certain disadvantages also there. You just search the internet and understand little deep. That's it. Coming to the SAN requirement. What is a SAN requirement? SAN is for every enterprise environment wherein large-scale industry, wherever they require high throughput and all those things, they will go for SAN. But it is not easiest, and it is not a easy way to implement SAN because it is a lot of infrastructure is required, lot of cost is involvement. Like for example, if you want to install SAN components, SAN storage server is not only sufficient. What is additional components are required? Just like switch. Here the switch we talk about to connect the network connections. Whereas to establish SAN from the storage server to client server, in between storage server to client server, sufficient infrastructure, a separate infrastructure need to lay down. That is in the sense, software, SAN switches, SAN switches is nothing but SAN is going to work on fiber optic, whereas a NAS is going to work on existing LAN network. This SAN is going to work on fiber optic. What is the fiber optic advantages? How the data transfer it? That's the reason this particular fiber optic, because fiber optic is meant for high transfer rates. In network also, they are going to use some fiber optic connections, how they are going to use the fiber optic connection in the network, how they are going to use in fiber optic in SAN. But SAN is going to work on fiber optic. How it is going to work? What are the components are required for SAN? Storage area network. What is the requirement? A fiber channel requirement required HBA, host bus adapter. Just like network interface, network card, we know how the network interface is look like. It has an RJ45 connection. Whereas in SAN, this fiber optic communication, to establish fiber optic communication, it requires a special card. That card is nothing but HBA, host bus adapter. Server side, it requires a host bus adapter card. At the same time, client side also, the special card is required, so that server and client both are ready for SAN communication. To establish, to connect between server to client, what are the components are required? In between, there are number of switches, SAN switches available, because number of client servers are looking for SAN storage. So each client is going to have an HBA card. All those HBA cards are going to connect through fiber optic cable, and it runs through switches. What are the type of switch? It is a SAN switch, fiber optic switch. So how it look like? What is the cable it is going to? Let's see. See, this is a cards, different types of cards. HBA card, host bus adapter. If you see here, there is a orange cable connector. There are types of cards, 2-port card, 4-port card. Here, comparing with a network card RJ45, it is one kind of cable. Only one cable will be there. Here in fiber optic, there are two-pair cable. A two-pair cable is going to connect together as a single. So how this fiber optic is going to work? What is the port configuration? What is the port we call it as? How it is going to send the communication, receive the communication, just for understanding. It is not required to deep analysis. What is the limitations? For a network card, we talk about 1 Gbps connection. Similar way, here in fiber optic also, we call it as 1 Gbps, 4 Gbps card, 8 Gbps throughput. Okay. So what is types of card? There are 2-port card available, 4-port card available. We need to understand at the same time physical address of the HBA card. What is the physical address of the network card? We call it as a MAC, MAC, Media Access Control. Here for HBA card, what is the physical address card? We call it as, what is that? I forgot. Okay, let me recall. So this physical address will be there. Anyone have an idea? Physical? Any idea? What is HBA? Physical MAC, physical address of HBA card. Worldwide port number. Yeah, I got it. Worldwide port number, WWN number. That is the physical address of HBA card. We should understand what is a SAN communication requirement. It requires on both server side and client side. It requires an HBA card. What is that HBA card? It sends a communication through over the fiber optic communication. What is the physical address? WWPN, worldwide port number, WWN, worldwide number. That's a physical address of the HBA card. So what is the SAN storage area network? what is the requirement on the server side? Whenever SAN storage server is available, definitely there will be an HBA cards. On server side, it should be there. At the same time, on client side, whatever the servers are looking SAN storage, on client server, that client server is nothing but my virtualization server. On that server, I should have an HBA card, host bus adapter. Clear? This is a storage concept, NAS and SAN. It is all depends upon according to organizational requirement. Which one you need to implement? Either NAS, some organizations only uses for NAS communication. Some organization only uses for SAN communication. If you want to implement SAN communication, we need to look for additional infrastructure to establish communication between server to client. What is that additional communication? Fiber switches, HBA cards, fiber optic cables. This is a separate network compared to the existing LAN network. Okay, this is a SAN requirement. So what is the comparison between the NAS and SAN? You can go Google it and understand advantages and disadvantages of NAS and SAN. Why we need to look for centralized storage? You should understand why we are looking for centralized storage. It avoids a single point of failure. That's the reason in virtualization we are not going to use local storage to deploy virtual machines, to deploy virtualization layer. Clear? So coming to the network, even network concepts also we discussed in this session, like Windows Server Administration. First 3 sessions are related to only hardware components. We discussed about few components, what is network card, what is hub, what is the switch, what is router, firewall. All those concepts are already discussed. What I'm going to discuss here, the most important points is I didn't cover these 3 topics in this particular Windows Server Administration hardware components. What is this? What is a VLAN? So before understanding VLAN, we should understand what is a LAN. LAN is nothing but local area connection. We know that whatever the servers are connected in a single network segment, that we call it as a local area network. What is a VLAN? VLAN is nothing but virtual local area network. How virtual local area network? Within my local area network, that in the sense, if I have a switch, physical switch, how all the systems we are connecting together. If I have a 10 systems in my room, all 10 systems, if I connected to a junction box, the switch, that main switch is, what's the difference between hub and switch? Hub is a passive device and switch is a active device. That switch we can manage, we can configure every aspect of the configuration, like how the traffic should flow, how to restrict the traffic, or what is the bandwidth of the traffic, everything we can configure on the switch. That is a manageable device. Here, in this particular switch, physical switch, how it look like. If you see the switch, different switches are available. See, this particular switch, there are 24 ports are available. Here, there are 24 ports are available. Port in the sense, wherever I'm connecting RJ45 connector, I'm connecting a cable to the port. I'm inserting the cable to this respective port. This port, we call it as RJ45 port. Now, if I connected all the ports together to this particular switch, I'm going to call it as a LAN, local area network. What is a VLAN? I'm going to create a segregation within the available network. I'm going to restrict the network broadcast, the traffic, how it flows. Within this particular switch, what I'm going to, here I have 24 ports available. What I'm going to do, Within the switch, I am going to create 6 ports as one particular group. And 6 ports, I am going to create one more group. That in the sense, what I am going to, how to separate that network out of the available 24 ports, I am going to create a separate local area network. How to do that? The network engineers are going to create by having a VLAN ID. VLAN ID in the sense, they are going to create a separate network for this particular ports. Out of available 24 ports, I am going to create a groups. First 6 port groups I am going to create and make it as a one group so that the finance systems can connect together. The finance traffic, network traffic only limited to only between finance systems. Other 6 ports I am going to connect to HR department. That whatever the traffic flows to that HR department, it flows within that 6 ports only. That packet is not going to travel to other ports unless until there is a requirement. How they are going to implement? By making a VLAN configuration. LAN is local area network. What is LAN? How do we differentiate LAN? A network segment. Whatever the systems are connected in within a network segment, that we call it as a local area network. For example, class C. What is a class C range? 192.168.1.xxx. That in the sense, we can connect 254 systems, we can connect in a local area network, that is class C IP address range. 254 systems I need to connect to this particular system. So that all 254 systems together become as a LAN. But those 254 systems, I need to differentiate how the traffic is going to flow. If the 254 systems, and out of 254, one system sending a communication to look for some information. What it is going to do, the packet is going to travel to all 253 systems and check, are you my destination? Are you my destination? It responds the broadcast and reaches for each network interface and try to get the information. So in the sense, one system sends in data and it reaches to all 250 other 253 systems within the network. So to get the communication. So they are going to restrict this communication. The packet should not travel to other ports which are designated. It has to travel to only respective destinations. How they are going to restrict? The network engineers are going to create a, within the network, they are going to separate different networks. What is a class A network? Class A by default /8 we call it as. What is a class B network? We call it as /16. What is class C /24? What is this /24/8? It is a network segment. How the network engineers are going to do? They are going to create a different network segments, and how they are going to differentiate network segment? By creating a VLAN ID. What is that? By creating a VLAN ID. That's a VLAN ID. So if you want to understand LAN and VLAN, VLAN is nothing but creating a separate network for this communication, packet travel communication. Why this VLAN is very much important? This, if you are not able to understand this VLAN concept, it is very difficult to understand the virtualization network concepts. So these are the basic components. Certain knowledge is very much required to understand the network components in the virtualization layer. How the traffic is going to flow, where it is going to reach. Okay. One more important, let me add here. Okay, coming to this port and port groups. What is port and port groups? Port is nothing but, again, coming back to this particular diagram. What is a port? We call it as a certain port, right? Port group in the sense, available 24 ports are available. I'm going to create as 6 ports I'm going to create a port group. How to create? I am going to separate by seeing this switch. I can say that 1 to 6 numbers are one group, 7 to next 12 one group. I can differentiate for my sake of interest, I can differentiate. But how the switch is going to understand? How the switch is going to understand this particular 6 ports are belongs to one particular systems, 7 to 12 port groups are belongs to one particular system. How the system is going to understand? This concept, the port groups, how they are going to separate this port group, the port and port group. For system understanding this port group, they are going to define the VLAN ID. What is a VLAN IDs? What is the default VLAN ID? If you, as soon as the network engineer is going to create a VLAN ID, that VLAN ID for system understanding, I am going to name it as a port group. This port group is finance. That in the sense 1 to 6 ports, what are the ports are available in this particular switch? That 1 to 6, I am going to make it as a finance. That is for my understanding. How the system, how the traffic, how the packet, data packet flows through. That packet is going to assign a VLAN ID for system understanding. That VLAN ID is nothing but the network engineer is going to assign a separate network. While creating a separate network, they are going to assign a VLAN tag. VLAN tag, that ID will be there. What is the default VLAN IDs? From where to where the IDs are available, VLAN IDs. You can Google it. What is the VLAN IDs range? We understood IP classes the same way. What is a VLAN IDs? What is the default range for VLAN IDs? Okay. Anyhow, it is not very much important. What we need to understand here, what is a VLAN? VLAN and LAN. How the system is going to understand this particular VLAN concept. So if we understand the VLAN concept, VLAN is nothing but it is for my understanding, I'm going to define as a port group, certain ports as a port group. For system understanding, there is a system code is required. That code, we call it as a VLAN ID. So port and port group, LAN and VLAN. What is VLAN ID? Who is going to create VLAN IDs, network segments? Who is going to provide IP information? IP information and network segment, everything is going to be provided by network engineers, network administrator. They are going to manage this particular switches configuration. Okay. This is for the VLAN and VLAN. How about trunk? What is a trunk? We know the trunk, elephant trunk. The same funda, the same principle is going to come into picture here. What is a trunk? Trunk is nothing but it is going to accept whatever the network packets it is going to accept in a single channel, single port. They are configuring. See, for example, in this particular diagram, how the packet is traveling from port group 1 to port group 2. Finance department need an access from the HR department. So the packet is going to travel from HR department to finance department to HR department. That in the sense, the switch, whatever the switch packet is going to travel from one switch. Here I am showing as one switch, but I am going to show different switches altogether. There are 1,000 systems are connected together. How the packet is traveling from one network to another network, how it is accepting all VLAN IDs in a some ports. For example, here I am going to create a 4 port group on this particular switch. 4 port groups means it is going to have 4 VLAN IDs. These 4 VLAN IDs are there in this particular switch. Similar way, another switch is there, and that particular switch also same concept. But these all packets need to travel from this particular switch to other switch. How it is going to travel? How it is going to send the communication? whatever the port we are going to use to send the communication from this particular to other switch, whatever the port we are going to use on that particular port, they are going to configure. Who is that? Network engineer is going to configure trunk configuration. Trunk in the sense it is going to accept all the packets through that port. Generally, that trunk port by default, it is going to be acts as an uplink also. What is the uplink? Uplink is nothing but, what is uplink? We need to understand uplink also. What is uplink? Uplink is nothing but, I have a room. There are 10 systems available. I have another room, 10 systems are there. Each room, there is a switch is there. All 10 systems are connected. And another room also 10 systems are there. All 10 systems are connected to that particular room switch. Like that, in my building, there are 10 rooms are there. Each room, 10 systems are connected. Okay, they are sending communication within the switch and able to send the communication for that room only. How to send that communication from one room to another room? How to access from one room to all other 10 rooms or all other entire building? So that switch is there in each room are going to connect together from one switch to another switch. They are going to connect together. Till now we understood that we connected our system, our laptop system connected to only one particular switch. I'm able to send communication. Now, whatever the communication is happening between the switch to switch, that particular port, wherever I need to connect a port, right? Whatever the port I'm going to connect here, from this particular switch, I need one port I need to use to connect to another switch. That whatever the port I'm going to use to connect another switch, that particular port I'm going to call it as a uplink. To avoid a single point of failure, I am going to use another port also to connect same switch. Between two switches, what I'm going to do, from one switch to another switch, I'm going to connect as a port communication. That in the sense, from room number 1 to room number 2, I'm going to send communication. How the communication is happening? I need to connect a cable between both the switches. Then only I can send the communication. Whatever the port I used to connect between the switch to switch, that port I'm going to call it as a uplink. On the same uplink port, the network engineer is going to configure trunk, because it has to travel. All packets need to travel. If the particular port is restricted to only one particular VLAN ID, that packet is not going to travel. So whatever the port I'm going to use here, that port I'm going to call it as a uplink. At the same time, I'm calling as a trunk port also. Trunk port in the sense, it allows all packets, irrespective of their individual VLAN IDs. The network engineer is going to configure on that port, allow VLAN ID 1, VLAN ID 2, VLAN ID 3 packet from this port to outside. Because all this, what are the systems? Finance systems connected, HR system connected, other departments connected. All systems need to access through this particular port only. So whatever the port is going to connect it to this other switches, switch to switch communication. Whatever the switch to switch communication is happening, that port I'm going to call it as a uplink. How many uplinks are available? It is all depends upon the respective network infrastructure configuration. If I have 10 rooms in my building, 10 switches are there, entire building. All 10 systems should connect with each other. How many uplinks are there? How to send communication? The network engineer is going to configure this configuration. How to send the topic. So whatever the port are used for switch to switch communication, it is meant for, I'm going to call that port as a uplink port. Okay, so you should not get confusion If you have any confusion, just go through that. Here in virtualization, the network concepts only depends upon the LAN, VLAN, where when the VLAN is going to come into picture, the port group concept comes in picture. Why the port group is coming into picture, the separate network segment. Once the port group is configured, they are going to assign a unique ID. That unique ID for system understanding, that ID is nothing but VLAN ID. VLAN ID. What is range? What is range VLAN IDs? Okay, just Google it and understand. What is a trunk? What is a uplink? So how many points we need to understand here in this network? Again, I'm telling you, storage, network, these 5 components, how the important with these basics. If you are not able to understand, it's very difficult to understand the virtualization. So each one you need to correlate the CPU resources and other RAM and storage is all other 4 components are one side. This network is one side. If you are not able to understand this network, it is totally mess. These are basic components. How the system is sends the packet, because we are installing number of systems on a single hardware layer. That single hardware layer, it is going to accept different networks. How the port group is going to accept, how the VLAN is going to come into picture, what is a VLAN ID. Okay, these are all important. See, this LAN. For remaining topics, you can refer to previous session, that is session number 3, network concepts. Session number 3 in Windows Server Administration, you can refer and understand the network concepts of other points. Here I am discussing only LAN, VLAN. When the VLAN is going to come into picture, port group. What is a port? What is a port group? Then VLAN ID. What is a VLAN ID? What is a trunk and what is an uplink? Everyone is interrelated to one. If you are not able to understand, please ask. I'll try to explain in a different manner. But understanding this network concept is very much required to understand the virtualization network layer. Virtualization is one part, virtualization network is other part. There are different concepts comes in virtualization network. While deploying the servers, how these things are going to happen, how the communication is happening. Without understanding network, you cannot troubleshoot the network components issues. So please concentrate on this particular points. What is LAN, VLAN ID, what is the range, VLAN IDs, what is a trunk port, we call it trunk port, what is the uplink. These are all components you need to understand by referring to the switch. Here, I'm calling as a switch in this particular topic here. If you are not able to understand the physical switch, how it look like, in virtualization, I'm going to talk about virtual switch. Here, we are going to see this physical switch layout. How many ports are available, how the uplink is happening, how the trunk port, all the packets are, how the all VLAN packets are traveling through this uplink. The uplink means the uplink port they are going to configure trunk. So here, this particular physical switch, I am going to replace in the virtualization environment with a virtual switch. So understanding this network concept and understanding this physical switch is very much essential to understand the virtualization concept of virtual switch. If you are not understanding port and port group, you cannot understand the virtual switch. You have to imagine how the switch is. Same, I am going to create a virtual switch. Virtual switch is nothing but It is a software component. There is no physical component available. Here, you need to correlate how the system is connected from one particular system to the physical switch. What is required? A network card is required. A LAN cable is required. With that LAN cable, I'm connecting to this switch. But in virtualization, what we are going to do on a physical server, I'm going to create a number of virtual servers. Virtual server, within the virtual server, virtual network card. Virtual network card. There won't be any port, physical imagination. There won't be anything. It is a software component. But you have to imagine there is a network card, virtual network card. There is a port is there. I'm going to connect a connector, and I'm going to connect the other end to the virtual switch. See, this is all imagination. This is all software code is going to happen within the virtualization layer, how the packet is going to travel. To understand that, first we need to correlate with the physical layer, physical environment, how the system is connected to switch. If you understand how it is connected in the physical environment, then you can correlate in imagination world, that is virtualization world, how the system, virtual network card can connect a cable. There won't be any cable. It is a logical connection. So you need to correlate each and every component by understanding the physical component. So coming back, this network concepts, what you need to go through again and again, try to understand 5 components: LAN, VLAN, port group, trunk port, offline. This is all about network concepts. So we are ready to go ahead with next concept, that is RAID, remote management and RAID card. Tomorrow I am going to discuss about remote management and RAID. What is remote management and RAID, and how it is important in the physical server environment. This is a small topic. Once this is done, we are going to install ESXi host on a virtual environment, that is our lab, VMware workstation. Our friend Srini is going to provide one live server. We are going to install on live server with the CD-ROM. How the ESXi host installation happens. We'll do on a lab environment, as well as we are going to perform the same thing on a physical server. So both things we are going to cover tomorrow once we understand remote management and RAID. Okay, that's it for today. Thanks for joining. Bye. Any doubts?